Hello students, this video is for the Interim Assessment 1 in 2016. I'm reviewing the short answer questions, the packet that I gave out in class. The first question that I'm going to go over is the walkway question. These walkway questions will fairly often take the same structure, and you'll see them throughout the course. It talks about a rectangular garden measuring 12 by 16, so we're going to annotate that part. It's a rectangular garden, measures 12 by 16, which is width and length respectively. The walkway that's installed around with it with a width of X meters. Sometimes it'll say a walkway of uniform width, which is the same idea. If they don't give you the width, it'll be X meters. The first part asks to write a polynomial expression to represent the length of the garden and the walkway. Well, the length is composed of three different parts. The first part of the length is the 16 part. That's from here to here. Right? The next part, well, there we go. The next part, or the next two parts, are going to be the walkway. And you can see that from the edge of the walkway to here, and from the edge of the walkway to here, are both the same amount. They're both X. So I'll fill those in a different color. So from here to here, and also from here to here. And I will label those as well. For this red portion is going to be the same distance as from here to here. That should be 16 meters. So we'll put that in red. Well, that is ridiculously large. That's our length. And then from here to here is going to be X meters. And similarly, from here to here is going to be X meters. The thing that they're going to ask you to do is try to determine the entire length of the garden and the walkway. So 16 plus X plus X. Instead of writing it like that, we'll simplify it. That's equal to 2X plus 16 meters. Similarly, we're going to write a polynomial expression to represent the width of the garden. That's a typo, shouldn't say T. And the walkway. 12 is from here to here. From here to here is going to be X. And also from here to here is going to be X. So it's the same idea. We're including two X's because there's two different widths of the walkway that we have to contend with. So instead of writing 2X plus 16, we'll write 2X plus 12. And as you can see up here, 12 is the width of this garden. Meters. In order to determine the total area of the walkway and the garden in standard form, we know that area is just equal to length times width. So we'll write it like this. Area is equal to the length, which is 2X plus 16, times the width, which is 2X plus 12. And I'll show you the distribution now. Here you can see I multiplied 2X times 2X, which is 4X squared. A common student misconception is multiplying these two and getting 4X. That squared is important because we're multiplying X times X, which gives us X squared. Then we do 2X times 12, which gives us 24X. You can see the next two multiplications, 16 times 2X, that gives us 32X, and 16 times 12 is going to give us 192. We have to write it in standard form so we can tell that there are two like terms, 24X and 32X. So we're going to rewrite it as 24 plus 32. That should give us 56X plus 192. If we're giving a real-world answer to a real-world problem, it asks for the total area of the walkway and the garden. So we need to include our units, meters. But of course, this is not just linear measurement. This is space inside measurement. So we're going to call it square meters. Now we're asked to determine the total perimeter of the walkway and the garden in standard form. So the perimeter is going to be a little bit different. Area is equal to length times width, but the perimeter is going to be equal to 2 times length plus width. We're taking the length plus width and we're multiplying it by 2 because we need all 4 of the sides. Length, width, and then another length, width. In order to do this, we'll fill in this formula with the information that we have. So the perimeter is going to be equal to 2 times the length, which is 2X plus 16, and the width, which is 2x plus 12. We're going to simplify this as our next step. I'll move this up a little bit. The perimeter is equal to 2 times 4x plus 16 and 12, which is 28. And now we're going to use our distributive property. We're going to give our answer as the perimeter is equal to 8x, which is 2 times 4x, plus 28 times 2, which should be 56. And finally, we need to use our units. In this case, it's not square meters, because we're not measuring space inside. We're just measuring distance around. So we'll call this meters. I'll go over a few more problems on this document. On the next page, I'm going to go over question number 3. It asks for the difference of negative 3x squared plus 6x and 12x plus 4 in standard form. It's asking for difference, which we know is subtraction, and it gives us the two polynomials here. So I'll set up the problem. Here's my basic setup with negative 3x squared plus 6x and 12x plus 4. It didn't ask us to subtract from, so we didn't switch the order, but there's one thing that we need to keep in mind. When we're subtracting two polynomials, we always need to encase the two polynomials inside parentheses. The reason we do that is because the subtraction process requires us to take that subtraction sign and distribute that negative into the all of the terms in the second parentheses. So it's going to look like this. And you can see I've distributed this negative sign onto both of the terms in the second parentheses, and now I'm rewriting it as a polynomial with 4 different terms. You can see that with this polynomial, there are two terms that we can combine, the 6x and the negative 12x. So we can call it 6x minus 12x, which is going to be negative 6x. And neither of the other terms have like terms, so we leave it like this. This is not a real-world problem, so I don't have to include units or anything like that. So that is how we find the difference of these two polynomials. Next, we're going to take a look at problem number, not 6, but 7. In problem number 7, it asks us to solve the equation for x. Solve the equation below for x. That means that we're supposed to isolate the x value. It also says in terms of a. So I want to be clear about what that means. In terms of a only means that your answer is going to include the letter a. So in terms of whatever it says there, it says the answer will have a in it. So once we solve this, it's pretty clear it's going to have a because there's so many a's in this problem. In order to isolate the x, we need to find where the x is and try to put them together. We have an ax here and an ax here. So what we need to do is put these together. My first option is going to be to do the distributive property. And you can see I distributed 4 times ax and then 4 times 3, which is 12. Now I have two like terms, which I will combine together, the 4ax and the minus 3ax. Now remember that when you're combining like terms, 4ax minus 3ax, I'm going to combine the coefficients, which is just 1, and then keep the a and the x, the variables, the same. This should be 1ax. I'm not writing the 1 because 1 times anything is just that same thing. That's the identity property. So ax plus 12 equals 25 plus 3a. Now we're going to try to isolate the x. We see that there are two things happening to the x. There's a plus 12 and a minus a. We're going to get rid of that plus 12 first by using opposite or inverse operations. We're going to subtract 12 from both sides. And we're going to get ax equals 25 minus 12, which is 13, plus 3a. And last but not least, I need to divide both sides by the letter a. And you notice that a divided by a gives us 1, so we don't have to write that. 13 plus 3a over a, we can leave it like that. There's another way that we can express this answer, and this answer is equally right. 13 divided by a plus 3. Notice that I did 13 divided by a, which I didn't know how to do, but 3a divided by a, we can divide a divided by a, which is 1, and we can eliminate the a from that portion of the answer. Either of these answers is equally correct. Now we're going to move on to question number 10. Question number 10 is very similar to one of the questions that we've done in class before, but I'll walk you through the steps. It says to solve algebraically for x. We're going to annotate that part. Algebraically just means solve for x using algebraic methods such as combining like terms and additive inverse, things like that. So 3 times x plus 1 minus 5 equals 12 minus 6x minus 7. We're going to first try to use the distributive property, and I'll write down the properties that I'm using. First, let me write the original problem, and I'm going to write given because it was given to me like this. I'm going to do the distributive property on this first part of the equation. That's 3x plus 3. I still have that minus 5x. And now I'll do the distribution on this second side. Keep in mind that I'm distributing this negative sign into the two terms in the parentheses. So I've multiplied negative times 6x. That gives me negative 6x. I've put that negative onto a negative 7, which makes it a positive 7. And for both of the things that I've just done, for both of these operations, I can say it's the same reason. Instead of saying given, I'm going to say distributive property. Next, I'm going to try to simplify each expression by combining like terms. So you can see I combined 3x and negative 5x into negative 2x. I combined 12 plus 7 into 19. And both of the things that I just did were combining like terms. Next, I'm going to try to get all the x values to one side by using the additive inverse. So you can see I added 6x to both sides. I'm eliminating that negative 6x on the right side. I now only have 19 on the right-hand side, and I have negative 2 plus 6, which is 4x, still plus 3. Now I'm going to get rid of that 3, eliminate that 3 using another additive inverse step. So I'm subtracting 3 from both sides, and I get 4x is equal to 16. That is an example of another additive inverse. Now, finally, I'm going to divide both sides by 4, and I'm going to use the multiplicative inverse. Now you can see I'm dividing both sides by 4, as I just said. So x is equal to 4. That's the multiplicative inverse. So I've solved this algebraically using a number of different properties explaining all of my steps. This is not necessary to do. This explanation is not necessary to do on a 4-point question. However, if you do it, then you will know exactly what you're doing. You'll be able to show your work, and you'll be able to keep yourself organized. Finally, let's take a look at the 6-point question. You're making n loaves of bread for a bake sale. Looks like a very wordy problem, so I'm going to annotate it. You're making 6 loaves of bread for a n loaves of bread for a bake sale, and the recipe calls for 3.25 cups of flour per loaf. You're also making n plus 1 pies. So however many loaves you're making one more pie. If you're making, let's say, 10 loaves, it would be 11 pies. If you're making 20 loaves, it would be 21 pies. The pie recipe calls for 2 cups of flour per pie. This expression can be used to represent the total amount of flour needed for making the bread and pies. So we're going to try to break down this expression into what this part means, the 3.25n, and what this part means, the 2 times n plus 1. First, what does the term 3.25n represent? Well, we know that that term represents the amount of cups of flour, which is 3.25, and n, which is the number of loaves of bread. So we know that 3.25 is the number of cups of flour per loaf. And when we say per loaf, that's for one loaf. N is the number of loaves. So if I take the per loaf cups of flour and I multiply it by n, the number of loaves, I get the number of cups of flour used for all of the loaves of bread that I make, all n loaves. What does the term 2n plus 1 represent? This n plus 1 is the number of pies. The 2 is the number of cups of flour per pie. So when we multiply those two together, we're going to get something very similar to letter A. So you can see that 2 is the number of cups of flour, n plus 1 is the number of pies. 2 times n plus 1 represents the number of cups of flour used for all the pies. For C, how many more pies than loaves of bread are being made? Well, you can look and see that n is the number of loaves, n plus 1 is the number of pies, so you can safely say that the number of pies is always going to be one more than the loaves of bread. And that leads to this confusing sounding sentence: there is one more pie being made than loaves of bread. In other words, if you count the number of loaves of bread and count the number of pies, the pies is one more. What are the units associated with the expression? Well, we remember that in the beginning of the problem, it talked about cups of flour. So we can express that as cups of flour. Letter E says, how would the original expression change if the same amount of pies were made as loaves of bread? The only thing that would have to change is the number of pies would change from n plus 1 to simply n. So let's rewrite the expression to reflect that change. So if this was the original expression, we need to rewrite it to reflect the change. All we need to do is delete the plus 1. So 3.25n plus 2n. It does not ask us to simplify, but if it did ask us to simplify, we would write it as 5.25n. How did the original expression change if one less pie was made? Rewrite the expression to reflect the change. If we need one less pie, we're doing n minus 1, which would look like this. Good luck studying, folks.